Assalamualaikum and hi. Basically, during our lecture video last week on Tuesday, 8 until 10 am, I forgot to record the class. So today I will record a new video actually just to explain again on that example 1 yang kita buat 2 weeks before yang belum habis, and also proceed with example 2 yang the one yang we should learn last week tapi I tak record the class So here we have example number 1. This one we did last 2 week, and then I proceed lah. As we already got the value, and what we need to do next is, because we need to design, then we need to find numbers of bars and the size according to the one that we assume in the previous class. Okay, we assume the main reinforcement size is 25 mm. Therefore, we need to use 25 mm, okay, in order to design for the reinforcement. And we look at the value of AS here, it is 1618.409. Therefore, we can select 1960 as long as the value of the cross-section area of round bars ni, the value that we select is higher than AS that we calculated. Then I can just write here, provide 40, 25, 1960 millimeter square. Then we can draw or sketch the beam that we design. 1, 2, 3, 4 must be according to 40, 25 that kita select tu and then the hanger bars. Then we can proceed to label the design. This is 40, 25, and we have 2T12 as the hanger bars, and we have R10 as the links, because R means that mild steel. It is given in the question. Dia dah bagi FYV sama dengan 250, so kita tahu it is mild steel. And 10 mm because kita ada assume dekat atas So bila kita assume dia 10 mm, kita kena stick dengan whatever that we assume. The D, which is the effective depth sampai centroid of the main reinforcement tu if the effective depth or D is 552, and we have the total height of the beam is 600 mm given in the question, because this is example 1. Dia dah bagi tahu okay, 600 mm dah. Then we can just use the 600 mm as the total height. So we need to find the balance down here. If the total H is 600 mm, so you just minus with the effective depth, which is 552. Then you will get 48 mm as the value, the balance dekat bawah tu, lepas daripada half of the main reinforcement tu, you ada balance dekat bawah tu. Right, so we are done with example number 1. Okay, and also during that day I also teach you example 2. Now we proceed with example number 2. A simply supported rectangular beam of 7 meter span carries characteristic that, including self-weight of beam, that load ni dah termasuk self-weight of beam, 12 kN per meter and 8 kN per meter for imposed load QK. The beam dimension are breadth B is 275, alright, and effective depth is D 450. Assuming FCU 30 Newton over mm square means that actually dia dah bagilah grade beam ni 30, means FCU 30 Newton over mm square. Fy is 460 Newton over mm square, means that Fy ni adalah high tensile steel, the reinforcement. Okay. And Fyv, which for the link is 250, means that it use mild steel. Therefore, if this one, biasanya you akan pakai T lah. T berapa-berapa. It's a symbol there. And for this one, is R lah. So, you tahu mild steel, you akan pakai R. Design the bending reinforcement. Shear ni tak ada kita tak belajar. So, what's the difference between this example 1 and example number 2? Example number 1 give you total height of the beam. Dia dah bagi height. Okay, and for this example, this is example 1. And for example number 2, dia just bagi effective depth. Okay, for example number 1, self-weight not included. Means that you kena kira. Tak ada tak termasuk. For example 2, self-weight ni dah ada. Then you don't need to calculate self-weight, tak perlu masukkan dalam dia punya GK, which is the total dead load. To calculate this one, we can simply calculate loading. Pakai formula, okay, ultimate load. Terus tak perlu kira self-weight lagi. So, kita terus kira ultimate load. 1.4 GK plus 1.6 QK. Then 1.4 you just times with the GK 12 kilonewton per meter and plus with 1.6 times 8 kilonewton per meter. You will get the ultimate load 29.6 kilonewton per meter. Next, we can move to calculate the man steel by calculating the ultimate design moment using the formula of WL square over 8. Steps dia lebih kurang sama je, so you don't need to worry, although you have lots of formula, but it is pretty generic step. The length of the beam is 7 meter. Okay, you boleh tengok pada gambar rajah ni balik lah. Check every time you calculate. Jangan asyik tiru je apa yang saya tulis, because value tak sama ikut soalan. You will get 181.3 kilonewton meter. Next, we calculate the ultimate moment resistance, because we need to check M must be less than MU in order the design to be singly reinforced concrete beam. Formula is 0.156 FCU BD square. Okay, 0.156 times FCU, which is 30 Newton over mm square, times B 275. Ini semua diberi dalam soalan. And value of D, we have it. Okay, sebab for example number 2 kita ada, dia bagi value D 450. Then it is 260,617,500 Newton millimeter. Okay, just simply padam je ni. Okay, and then this one also dia hilang lah sebab millimeter kuasa 2 kan. Okay, so dia hilang dekat kuasa 2 ni, hilang lah. Okay, so 450 tu masih you kena kuasa 2 kan bila you kira. Then this is jawapan kita lah, Newton darab dengan millimeter, which also equal to, kita nak tukar dia into kilonewton meter sebab kita nak compare with the value of M divided with 1000 millimeter to meter, and divide another 1000 Newton to kilonewton. You will get 260.617,618 okay, kilonewton meter. So from this value, you see that M is actually less than MU. because 181.3 is less than 260.618, which means that no compression reinforcement is required. Then you can just design as singly reinforced concrete beam. After this, kita boleh terus kira value of K using the formula of K equal to M divide with FCU BD square. We know that it is 181.3, which is in kilonewton meter. So anything in kilonewton meter, bila kita masukkan dalam formula K, we must make sure that dia dalam newton dan millimeter. Sebab FCU adalah dalam newton over millimeter square. So mesti newton untuk berat, and millimeter tu adalah untuk anything yang macam panjang, area ataupun volume dan sebagainya. 100.3 okay, kilonewton meter, convert into newton, dan you darab 1000 and darab lagi 1000 to convert from meter to millimeter. Divide it with the value of FCU, which is 30, and B 275, and the D is 450. Then you will get the value is 0.109. We need to compare dia dengan K prime, which is 0.156. So obviously value yang K ni kita dapat less than 0.156 ataupun K prime, which mean it is okay sebab M is less than MU. So K macam mana pun akan less than K prime. Then we calculate for Z using the formula of 0.5 plus, I forgot the D, okay, square root 0.25 minus K divide with 0.9 D, okay. Okay, so you akan dapat 0.859D, which the value is less than 0.95D. So we going to use 0.859D ni untuk masukkan dalam formula of AS, steel area, sebab dia less kalau dia lebih besar pada 0.95D, kita akan ambil value 0.95D. Proceed with AS, which is the steel area. M is 181.3 times, saya terus darab 10 kuasa 6 sebab you tahu 10 kuasa 3 darab 10 kuasa 3 tu yang kita kira masa kita kira K tu, okay, sebab kita tukar kilonewton to newton and meter to millimeter, so sama je lah. Then we divide it with 0.95 times Fy, which we know that dia pakai high tensile steel 460 for the main reinforcement, and again times with Z 0.859 and times with D, which is 450 mm. Okay, sebab 0.859 D. Okay, jadi kena darab D lah for this. I get here 1073.274 millimeter square. Okay, so we need to look at our steel table here so that kita boleh pilih suitable design for the beam. According to the last class, if I'm not mistaken, okay, I believe that one of you suggested that 6012, which is this one lah. Okay, 6012, and the other Adriana, if I forgot the name, I rasa lah. Another one suggested 1260. Okay, but 1260 kita buat dalam kelas tutorial kan minggu lepas. So I pakai 1010 this one lah, because one of you suggested 16. Okay, because dalam soalan ni dia tak specify berapa diameter of the bars that you have to use. So you just boleh ambil any size of the bars that you wish, as long as it fulfill 1073.274 ni. So 60 16, we just write here from table, provide 60 16, which the AS is 1210. So first what we need to do is we need to check for spacing. For spacing, if this one I'll do a single layer, no stacking, then we just use the B, which is 275 minus with 6 numbers of 16 mm diameter of bars, minus with 2 times 10 mm diameter of link. Assume diameter of link, kita assume saja. Dia tak ada bagi saya pakai size apa. And minus with 2 sides of concrete cover. Then we can divide it with the total number of bars. Okay, number of bars minus 1, sebab kita tak buat stacking. So kita assume beam tu macam ni 1, 2, 3, 4, 5, 6. So spacing yang ni yang kita nak ni, yang kecil-kecil ni yang berapa? Sebab single layer sahaja. So we divide it with 5 lah. Okay, sebab ada 5. 1, 2, 3, 4 dan 5 in between bars punya space tu. Then I get 21.8 millimeter, which is, this one is tak okay because it is less than H aggregate, which is the aggregate size maximum plus 5 mm. Okay, normally kita pakai aggregate size 20 mm, so 20 mm plus 5 mm dia jadi 25. So value ni tak cukup, so tak okay, not okay. Then we need to dapatkan dia sampai okay. Okay, what you can do next is whether you can just directly pakai je 40-20 and check for the spacing, or you can still pakai 60-16 but kita opt for double layer ataupun stacking. Okay, jadi bila kita pakai stacking, kita kena kira another time for spacing 275. So for stacking bars ni kita tak assume dia like this. What we do is kita tak susun dia macam tu, kita susun dia berkapal macam ni. I need to remind you, dia mesti berkapal. Bila dia stacking, dia mesti ada gang. Okay, maksudnya kalau you couplekan dia dua, ada dua lah. Okay, tak boleh yang kat sini you letak dia 1, 2, lepas tu 3, 4, dia letak 5 numbers of bar, satu kat tengah-tengah tu tak ada kawan. Dia mesti hidup berkawan Since dia macam ni, so you nampak bila you nak tolak tu, obviously you akan tolak dia dengan you tahu B dia 275. So 275 you kena tolak dengan 3 numbers of bars sebab dia duduk berstacking. So tolak 3 number of bar. Okay, and then tolak dengan link sebab you nakkan spacing je kan in between tu. So you dah tolak link, so link ni punya width hilang diameter dia. And then you tolak lagi dengan concrete cover. Okay, what's left here is this spacing. So space dia bahagi dengan 2 sahaja, bagi 2. Bukan bahagi dengan number of bar minus 1 sebab you letak dia stacking. So we just write here, so because of dia dah stacking, jadi dia 3 numbers of bar minus with 2 darab 10 mm. Yang lain-lain ni samalah. And okay, divide ni dia bukan bahagi 5, dia bahagi dengan 2 sebab spacing in between tu, sebab kita dah stacking kan, dia spacing dia 2 sahaja. Okay, nak nampak better you draw. Bila you draw baru you nampak. My value is 78.5, which is okay, bigger than HAGG plus 5 mm, aggregate size plus 5 mm. So when this is okay, we can finally draw for the design. 1, 2, Okay, sebab kita stack dia, so kita kena lukis dia a stack lah. We also have a hanger bar up there, right? And we need to label, right? So you know that this is 60, 16, 2T12 as the hanger bar. R10 link, okay, 10mm, assume R to specify in the question, dah bagi FYV 250, so you tahu dia lah R. We also have the value of T yang kita kena letak. Okay, so D kat sini is 450. Okay, itu adalah our effective depth. Okay. Value yang bawah ni we don't know And we must also remember that dia punya D tu adalah sampai in between bars tu, sebab kita letak dia stacking. Okay, mesti berada di tengah-tengah lah antara dua bar tu. Jadi dia tengah-tengah Therefore, we need to calculate for H. H is equal to D plus, okay, not half bar, it is going to be full bar. Sebab you ada full bar down here. Kat sini ni full bar. Okay, sebab D tu dah sampai first bar on top. Bawah dia dah ada lagi satu bar, full bar. Right, and then you have link punya diameter and plus with C. So D is 450mm plus with 16mm diameter of bar plus with diameter of link, assume, and 25 is the concrete cover, which you're going to get 501 mm total height. So 501, this is not a number yang okay, sebab kita takkan letak nombor 501, 502, 503. Kita tak sama ada kita tak belakang tu 5 atau kosong, sebab kita tak pernah cakap the size of the beam is 200 times 501. Tak ada kita cakap the size of the beam is 200 times with 510. Like that nombor dia genap ataupun 505. So I just round it up to 505. Macam mana pun you kena round up. 501 ni minimum sebab you ada 25mm concrete cover. Means kalau you letak, you round it down to 500, nanti concrete cover you hilang 1mm. Okay, concrete cover jadi 24mm je. Okay, that's why kita tak boleh round down. Better lebih daripada kurang. So I letak sini 505. If you want to put 510 also can. Tapi jangan lampau-lampau lah letak sampai 600, sebab kalau 600 nanti concrete cover punya tebal. So sebenarnya aesthetically lah, thick beam is not preferable lah, sebab dia mengganggu estetik. Jadi kalau boleh kita nak pendekkan beam tu. Maksud saya nak kurangkan ketinggian. Kita tak nak dia tebal-tebal sangat. 505. Therefore, we know that in order for you to get this value, okay, so 505mm just minus with 450mm. Therefore, you will get 55mm. Just put here 55mm. Okay, so saya stop sampai sini because yang 40, 20, 20, if I'm not mistaken tadi I tulis, yep, 40, 20 tu saya masuk masa kelas tutorial kan. Jadi saya stop sampai sini So thank you semua, have a nice day.